This lesson is on trigonometric functions of any angle. The essential questions for this unit are: how do you evaluate the trigonometric functions of any angle, and how do you use reference angles to evaluate trigonometric functions? So let's use the figure that I've shown you here. Theta is going to be the angle in standard position with x and x comma y a point on the terminal side of the angle, and r is equal to the length of the line from x comma y to the origin. So using this figure, we can come up with definitions for the trigonometric functions of any angle. So by definition, the sine of theta is going to equal y over r. The cosine of theta is going to equal x over r, and the tangent of theta is going to equal y over x. Okay? Now, if you were to take and construct a right triangle here, you would see that, yes, these do agree with the basic trig functions using a right triangle. So now if you look at how I've drawn the right triangle, and you can see how we come up with the y over r, x over r, and y over x. Now, these are the three basic trig functions, but what about the other three reciprocal trig functions? So cosecant theta is simply equal to r over y, secant theta is equal to r over x, and cotangent theta is equal to x over y. The reciprocals of what sine, cosine, and tangent are equal to. Now, one additional thing we have to be careful about is the fact that x and y are not always positive numbers. When we're in quadrant 1, x and y are positive, but if we move to quadrant 2, x becomes negative and y is positive. Quadrant 3, they're both negative. Quadrant 4, x is positive and y is negative. Now, of note, r is always going to be positive, okay? So whatever quadrant we're in, r will always be positive. However, x and y are not always positive. So as a result, these trig functions are going to yield results that are in some cases are positive and in some cases are negative, depending on which quadrant you're in. So now if you look at the image that I've added here, you can see that in quadrant 1, all the trig functions are going to be positive because x and y are positive. R obviously is positive because r is positive in every quadrant. We move to quadrant 2, r is still positive, y is positive, but x is negative. Okay? So therefore, sine and cosecant, which don't include x, are going to be positive. Okay? But the other functions, cosine, secant, tangent, cotangent, because they include x, are going to be negative. So the only positive trig functions in quadrant 2 are sine and cosecant. Moving to quadrant 3, both x and y are negative. So therefore, tangent and cotangent, which include x and y, negative over negative is always going to be positive. So they are the only two functions that are going to be positive in quadrant 3. Finally, moving to quadrant 4, x is going to be positive, y is going to be negative. So therefore, the only functions that are going to be positive in quadrant 4 are going to be cosine and secant. Since they do not include y, they only include x. So using this figure here, you can tell, depending on which quadrant the angle is in, whether the trig function is going to be positive or negative. Now, the values of the trigonometric functions of angles greater than 90 degrees, or less than 0 degrees for that matter, can be determined from their values at corresponding acute angles called reference angles. So what do we mean by a reference angle? The definition of a reference angle is that it is the acute angle formed by the terminal side of the given angle and the horizontal axis. That's very important. Everybody wants to make the reference angle to the vertical axis. It's to the horizontal axis. With quadrant 1 angles, there really isn't a problem because all angles in quadrant 1, or in other words from 0 to 90 degrees, are their own reference angle. So quadrant 1 is not an issue, and all the angles are their own reference angles. In quadrant 2, as you can see, say our angle is 120 degrees, which brings us into quadrant 2. The reference angle is 60 degrees. Again, remember, it is the acute angle formed by the terminal side of our given angle and the horizontal axis. If you wanted a formula for this, so using a formula, the reference angle is simply equal to, whenever you're in quadrant 2, 180 degrees minus the angle theta. Or in this particular case, and if you look at our figure here, it's 180 degrees minus 120 degrees, which gives you 60 degrees. Now, obviously, if you were dealing with radians, the reference angle would be equal pi minus theta, okay? But in our particular case, we're talking degrees. Now, if our angle is in quadrant 3, as this new figure shows, again, the angle is going to be with respect to the positive x-axis, with respect to the horizontal axis, I'm sorry. So our theta angle in this case is 240 degrees, and the reference angle is going to be with respect to the horizontal axis, so it's going to be 240 minus 180, or 60 degrees. So as you can see, our formula is simply theta minus 180 degrees. Again, if we were using radians instead of degrees, it would be theta minus pi, since pi radians is equal to 180 degrees. So finally, if we're in quadrant 4, the reference angle, we take 360, which is the full circle, minus 315, and we come up with a reference angle of 45. So our formula now is the reference angle is simply equal to 360 degrees minus theta. Again, if we were in radians, it would be 2 pi minus theta. So now I'd like you to do the following checkpoint problem, and that is to find all 6 trig functions, or evaluate all 6 trig functions, for an angle of 150 degrees, and post your answers in the drop box.